Hello, Alexander physics students. I'm going to try to get 13 and 14 done. But these are challenging problems. There's no doubt there. I'm very happy with the way you guys are battling on and struggling and asking questions. Great job. But these are tough questions. So I'm going to go over them and we'll see how we do. So, all right, this is problem 13. And it is the pendulum. All right. Okay, so what we have is, all right, we have a pendulum coming down here. All right, so what we know that this is 0.749 meters. I turned it to meters. It was centimeters. I just moved it over to the left. 1, 2, and there it is as in meters. You got to turn it to meters. Okay. So you want to know what the tension of the pendulum at the cable at the point if the pendulum is this, at the lowest point. So here it is. And when it swings down here, okay, what is it? Well, we have two forces. Okay, we have, okay,
it's empty.
FG pulling down, and we have F, we'll call it C, for centripetal force. So, what we're going to do is we're going to calculate these two. So, FG is mass times gravity, and if we do that, it is 0.300 times 9.81, which is, oh, that's awesome, Alex, nice. Oh, cool, yes. And when we multiply those two, I have my numbers everywhere, so you have to bear with me. 2.943 newtons. Okay, now how about FC? Well, it's MA as well. But this A is for centripetal acceleration. So we need to calculate that. And that is equal to the velocity squared times divided by the radius. And we're given that. So awesome. So I'm just going to go down here and running out of room here. Already, I fear for the next problem actually. So AC is V squared over R. And in that case, it is 3.28 squared over, and my units play nice, so that's why I turned this to meters. And then when we do that, I end up with 14.36 meters per second squared. Now, that goes up here, and it's 0.3 times this 14.36, sorry, this value here times our mass times acceleration, centripetal acceleration, and when we do that, we get 4.308 newtons. Now, we know this is an equilibrium, so what does the tension in this have to be? Because it's not flying off. The string is holding, at least we hope it is. If not, it's a whole other problem entirely.
Dad.
Yes?
Which symbol do you like better, that symbol or the dragon symbol?
Ooh, that's tough. Probably the octopus is cool. All right.
You
so
cannot use this for a different view.
Yeah, or you could put them both on there. All right, so we're going to add 4.308 plus 2.943, and that gets us 7.25 newtons. And that's this right here. Check. Done. So, not terrible, but also not trivial. So, okay. Whoa. I have more room? Ooh, I did not realize that. I have just now have all the real estate I need. Excellent mistake by me. Okay. Now we need, when the pendulum reaches highest point, what angle does it make with the vertical? Pendulum reaches its highest peak. All right. Well, we need to find out how much energy. So this is part 2. We're going to call this part 2. Okay, and we're going to do part 2 right here. So how much energy does it have? Kinetic energy. You could actually do the kinematic route too, people. I'm doing the energy route. And when we do this, it's 0.3 times 1, oops, I'm going out of order here. So 1/2 0.3 times our velocity. At the bottom, all its energy is in this. And that energy is 1.61376 joules. So now all that energy, if it turns to height, I want to know how far this thing will swing up, right? How far does it swing up? So what is this vertical height? Well, we can turn that to potential energy because all of it gets changed. It does not lose it. So it's going to be changed to potential energy. And that's mgh, which is 0.3 times 9.81 times h. And so you divide this by those two, and we get this. That's the worst h ever. We get an h of 0.5483 meters. All right. Oh, can I have more room? I thought I could create more room here. Oh, well, we're going to run out. We might have to do 2 parts of this video. Okay, so now at this point, we have, that's this here. All right, so I'm going to make another triangle here. So what's this? That's this total length minus this length. So this length is 0.2007 for me. So you see how I got that? This total pendulum length is 0.749, and then this is the height that this thing swings back up. And so that, obviously not to scale, but this is that height there. So we're going to make a triangle out of this, okay? And our triangle is going to look like this. So we'll have and this length is 0.749, and we want to know theta, okay? We have to find theta, so we can do the inverse cosine of 0.2007 over 0.749, and that will equal this angle in there. So we got to do an inverse cosine to get that. And so this angle for me is 74.46 degrees. Okay, so how does that help us? Well, what we need to do is we need, oh, that's our angle. There we go. Check. I just solved for it. Excellent. There we go. That's part 2. Done. Part 3 now. Part 3 wants the tension, so we're going to need that part. Okay. Okay, so part 3. And this is answer 3 here. So part 3, we want the tension. So we're going to use part 2 in this. So we want this tension at that highest point. So we have our pendulum. All right. And we know this is 74 point, I'm going to call it 5 degrees. Okay. And we have a couple forces to worry about. All right. So actually the velocity is 0, so we have one force to worry about, this force due to gravity. So here is this force due to gravity, and then remember, this is the hypotenuse. That's one of the most things. Notice how I made this weird looking right triangle here? to split this. That's a right angle. I'm splitting this so that this FG is the hypotenuse. It's pulling straight down. You can't split gravity and have it be the piece be larger than the actual gravity itself, force due to gravity. So this is a leg of that right triangle, and this leg will be equal to our answer, which is this FT here. This is complex, I understand. So if we have this triangle right here, do you notice this angle will be equal to this? So I'm going to draw this green triangle again right here. So this is FG. This, we'll call this FGY if you wish. And we don't care about this right here, but this is 74.5 degrees. Okay? So this is this triangle right there. So we know gravity, and then we just need to split it and find this, and that will be equal to our FT because it's in equilibrium there. And there's no centripetal force because it's at its peak. What is our velocity of an object at its peak of motion in the y direction? If you want to think of it that way, it's 0. This thing is not moving when the pendulum is at its very peak of motion. It's got a velocity of 0 for that instant in time. So this is just mg, right, which we have already done over here, right? So we don't need to redo that calculation. It is 2.943 newtons, but we got to split it. It's this leg of it. So the cosine of 74.46, or 5 for me, is equal to x over 2.943. And when you do that, we get an x, which that's our ft for this part 3, and I get 0.786 newtons. Alrighty, and that is it right here. Check, check, and check. That is all 3. That is a lot. Give it a try. If you get a couple parts, excellent. Remember, 100% will not be the entirety of this kappa. There'll be a scaling of it. And of course, if you get over the threshold amount, you get bonus, like many of you did in the last kappa, which I was impressed with. So you can obviously get them all done and get some bonus points, or you can, if you get a few wrong, that's okay. You can still get 100% on our score for it. So I hope you're doing well, and hope you have a joyous Easter. So I'll try to get 14 done. No promises. As you can hear in the background, there's some shenanigans going on. So, all right. Stay safe, physics.